Hello, welcome, guys. I hope now you're so proud of yourself because now you can actually grab logis, okay? But now we're gonna actually go down to the next topic, which is LOL, but not really. It's called laws of logis or logarithms, laws of logarithms, or they're also known as properties of logarithms, POL, okay? But I like LOL better. Okay, LOL. All right, what are the laws of logarithm and how do we apply them? So right now I'm going to show you a series of couple of basic things about logis, okay, logis. Again, you have to understand that base b, always that b is greater than 0 and b does not equal 1 because that's the only way logarithms make sense. Remember that? Like 0 to something power, that doesn't make sense. And 1 to a continuous power, that means it just becomes 1. So this is a basic one we have to know. If you have log base of b, that's going to equal 1. Let's check. B to the 1 equals b, right? That makes sense, right? Because if we do this exponentially, it's b to the 1, that equals b. Okay? So when you have the same base and the answer here is the same, that means these guys must be, they just go away and becomes 1. Okay? So let's try that. Logi 2, that equals 1 because 2 to the 1 equals 2. All right? Next, logarithm of 1. Let's try this one, okay? Logi base b of 1 is equal to 0. Let's check that. B to the 0 is equal to 1, right? That makes sense, okay? So anything, logi could be, I don't know, 50 to the 1. That's going to equal 0, okay? Keep that in mind. All right, so you guys, now here are the POLs or the LOLs of logis. For any positive numbers, m, n, and b, where b is not equal to 1, the following properties apply. This is all from your book. So you guys, this is product property. Product property, okay? It says, I'm not sure you can see it, so I'm going to write it as I say it. Logi base b, when you multiply m and n, you can actually write that. This is called an expansion. Logi base b m plus logi base n. But you guys, you notice that if I expand it, the logis repeat and then m and n are separated. But if I condense this expansion to this, you only say the logi once. I know that's going to be a little problematic, okay? Here's the quotient property, okay? So we have logi base b m over n. So dividing is going to equal logi base b m minus logi base b n. So we separate, but we subtract when we quotient. Power, we're taking the logi base b, and we're taking m, and we're raising it to a power. That's going to equal n logi base b m. That means the exponent comes to the front, and we multiply that logi out, okay? Now, using just these three, we're going to go through a series of examples here, okay? Part 1, using the POL, and this is the novice level, okay? So you guys, let's look at this problem, number 12 from your book. Logi, now remember, the default base, if not written, it's going to be 10. So logi base 10, 8 minus 2, logi 6 plus logi 3. So usually they're going to say simplify, and you should know what it means by simplify, or it's going to ask you to condense. Because right now, it's actually expanded, okay? So we're going to try to condense it. So you see that subtraction here. You see there's a times of 2 here, there's a product of 2 here, and there's logi 3 here. So let's see how we can do that, okay? We just move along from left to right. But you guys, logi 8, we can't do much. But this 2, can't we use a power property? So this is going to be logi 6 to the power of 2 plus logi 3, okay? Now, you see how this is a positive and this is plus? That means these must be products, okay? So it's going to be logi 8 times 3. Again, the bases have to be the same too. All over, and this must be a quotient since it's minus. So it's going to be what? 36 because it's 6 squared. So the answer is logi base 10, 24 over 36. Or we can actually write that as logi 2/3. It's the same thing, right? Because we're saying 10 to the power of something, right? It's going to equal 2/3. All right, that's what we're essentially solving for. All right? And remember, whenever we're solving logs, it means we're solving for exponents, okay? See if you can understand that. So you see, this whole thing had to be condensed into one single log. All right, let's try a couple more. It's very difficult here, huh? So we're going to try a couple more, okay? Express all this. All right, here's the second example. Express 3 log base 6m minus log base 6n over 2 as a single log. So this has to be all condensed. Again, this is condensing, okay? So let's do this. So first have loggy base 6m, but look, the power rule, so it's 3. And you see this is minus, but you see this guy, isn't it really a half, you guys? So it's going to be loggy base 6n to the half, right? Don't be surprised by this guy, okay? It doesn't matter whether it's below the entire loggy 6n, okay? So we get loggy base 6, all right, m cubed minus, so it must be the quotient rule, over square root of n. And we're done, okay? Now in loggy's case, it's okay if you leave this, don't rationalize this. It's okay if you just leave it like that, okay? All right, let's go to the next one. Why don't you guys try this one on your own, okay? I'll give you a few minutes. Stop the video. All right, I hope that you've worked on it a little bit. Now here, expand. So it's been condensed. We're going to expand it. So I'm going to separate all these. It's product rule, right? So I'm going to go plus loggy base 7x plus loggy base 7y plus loggy base 7z. Is that what you had? That's good then. Now here, I want to see if I can simplify this more, and I can. Isn't this actually 7 squared, you guys? Plus loggy base 7x plus loggy base 7y plus loggy base 7z. Now, look here. You remember this? Base 7, 7 to the second power. That's actually the power rule, so the 2 comes here. But what's 7 of 7? It's just 1. So that's actually going to become 2. Ask me why, okay? And then your answer is going to be loggy base 7x plus loggy base 7y plus loggy base 7z. That's your final answer. Your solution is here, okay? All right, let's go through one more. Express in terms of loggy base 10a and loggy base 10b. What does that mean? It just means to expand, really, okay? Oh, you know what I mean here, right? Base 2. Sorry about that, guys, okay? So it just means to expand it, okay? Let's expand this guy. Isn't this really, you guys, loggy base 2 mn to the negative 1 power? Okay? And try finishing now. Stop the video, okay? And I'm going to use a power first. It's negative loggy base 2m. Okay? I'll just write it like this for now, okay? But you guys, isn't this the product rule? So it's negative loggy base 2m plus loggy base 2n, okay? And distribute the negative, and then you're done. And there's your solution, okay? All right, now we're done with the novice level. Let's go to the superstar level, okay? Superstar level, you ready for this? All right, make sure you ask any questions. Let's go here, POL superstar level. I want you to express as a single logarithm, okay? All right, let's go through these. Whoa, these are expanded, right? So we're gonna put it into a single, all right? One single logarithm. So your final answer should actually have only loggy base 2 of something. And we'll see what that is, okay? All right, let's go through this. Let's go here first. Remember, we have loggy 2 base 2. So loggy base 2a. Now, how do we get this 1? Using a base of 2. So loggy base 2, how do we get this to be a 1? Yep, you guessed it, it's 2. So we have to rewrite that, okay? Be careful with this one. Plus, now this guy, let's simplify too, you guys. What does this 1/2 mean again? Isn't it loggy base 2, b to the 1/2, or square root of b? Okay, I simplified a lot of it. I simplified this guy to this, and then that. That one didn't need anything. Now we're going to try to combine everything. Well, isn't it all a sum? That means it's a product, right? So it's loggy base 2, right? Actually, I can start writing the answer right away, huh? So I'll write it right here, because we were set up for it. A, so you said 2a, right? 2a and square root of b is what the solution should be. Now ask me if you have any questions, okay? All right, expand. So you try this one now. Okay, go ahead and try. Stop the video. All right, I'm assuming that you tried. So now I'm going to move right along. Expand. So I know there's a product between these. So I know that I have to go log base 3, 7, plus log base 3, 2x minus 3 squared. Okay? But I also know that log base 3 is 7 plus this guy is a power. So it's 2 logi 3, 2x minus 3. And that's it. I'm done. So when they tell you to expand, you shouldn't have an exponent here. You should always use the power rule, okay? Now, whoa. Okay, number 57, express as a single logi, all right? So single logi of this, whoa, okay? Don't think it's impossible, all right? But you guys, remember what this guy means? It's the power rule, right? So let's distribute that first. So logi base x, 4 to the half, or square root of 4, right? Plus logi base x, y to the half, minus 3 logi x z. Oh, you guys, we could have done something here too, right? What does that really mean? It means the z cubed. I know that's what you were thinking, okay? Now, I'm going to go like this. Logi base x, square 2, right? Because square root of 4. 4 to the half is 2, plus logi square root of y, x here, minus logi base x, z cubed. Single log, ready? Plus, that means it's product, minus means quotient. So logi x, I'm going to write that big, 2 root y all over z cubed. And that's your solution. All right. Now try it if you dare, because we're going to move on to the change of base formula now. Okay? All right. Change of base formula. Ready for this? So you guys, those of you that don't use the TI Inspire, this is going to be really good for you. Okay? All right. Change of base formula. So you guys, you know how the default base is 10? Well, we can actually use a calculator to, we don't always have to change the base in your calculators. We can actually do that manually. For any positive numbers, m, b, and c, with b not equal to 1 and c not equal to 1, this is true. It doesn't matter what the c is as long as the bases are the same. But if you have log base bm, you can actually write that using any base of c. This is the m, and the b goes on the bottom. Okay, so I'll give you an example here, okay? So what if I have logi for 100, okay? Change of base formula, you could plug in your calculator, log 100 over logi 4, and it'll be the same answer. Same answer. They're all equal, okay? That's what that means. And this could be base 10, or you could put base 5, whatever you feel like, okay? But remember, the default is 10. All right, use a change of base formula to evaluate, okay? So you guys, we have logi 2, 9. So that could actually be written as what? Because I know the base is not a 10 here. So it's logi 9 over logi 2. If you wanted to get really creative, you would get the same answer, okay? If you want to get creative, sure, you could do logi 20 over 9, logi 22. Same answer, okay? Now you write this one. Okay, did you get this? This is applying the change of base formula. Seems silly, but we used to have to use this a lot before there were these fancy things on the calculator, okay? All right, now we're going to actually move on to the last part, all right, where we combine all the things that we just learned and put it into one. So you guys, use LOL or POL to evaluate logis. Number 41, logi base 3, 27 minus 2 logi 3, 3. Whoa, okay? I know that you probably recognize a lot of different things. But what I like to do, you can do it so many different ways, okay guys? But how about this? Isn't this a minus? So you know it's a quotient rule, same base, that's good. So you guys, isn't this actually logi 27 minus 2, not 2, I meant to write, oops, sorry. All right, logi base 3, 3 squared, okay? So isn't this actually logi 3, 27 divided by 9, because it's the quotient. We condensed it. So we get logi 3, 3 is equal to 1. Now, I want you to try another method of doing this on your own and see what you can come up with. And show me. Okay, show me. Try a different method. Okay? There's so many different ways. Okay, you could have actually changed it to 3 cubed. You're right. And then see what happens, okay? Let's go here, okay? Whoa. So I like to keep it consistent, okay? So I'm going to try this guy. Make sure they're the same base. Let's simplify first step. Try it without my help by turning off the video. Logi base 4. Isn't this really square root of 9? Can we get to that now? Okay. So now we get logi base 4, 48 divided by 3, isn't it? Right? And it's logi base 4. What is that? 16. But now, okay, but now, isn't this actually logi base 4 squared? And applying the power rule, isn't it 2 logi 4? But what's base 4 of 4? That's going to equal 1. So the answer is 2. And if you don't understand why it's 2, please ask me, okay? Now go ahead and try on your own. Have fun! Bye!